Alright, this video is going to be a conceptual overview of our character controller. So our character controller is the component responsible for moving our character around the world. So let's say that we have a platform that we're standing on, right? And then we have a slightly bigger platform that we might need to jump on, and then that falls off onto, something like this. So let's say our level looks something like this. And no, I'm not an artist. That's Steve's job.
It's beautiful, man.
This is the best level ever.
It reminds me of Limbo.
Yeah, I guess with the black and white color scheme. Okay, so we have our player, and so we're going to be modeling our player as a box. Now, you might be saying, well, our character is a circle. Well, yes, but the character controller is actually going to be a lot easier if the player is a box. You also might be wondering, okay, well, you might have used Unity before, and if you have, you might be wondering, well, Unity comes with built-in character controllers. They're not built-in, but they're available under standard assets. And unfortunately, Unity still hasn't provided a standard asset for a 2D character controller. In that case, I mean, we're going to be forced to write our own in some sort of way. And if you've used Unity before, you might be thinking, okay, well, that's actually really easy. We just make the character controller a rigid body, and then our entire world is a collider, or a collection of colliders. And then we can know, when the player is down there, we can add force to the player and he'll move. And then, for example, he'll stop right here because the rigid body will collide. And then we can add some vertical force to him, and that'll move him up here. And then once he's up here and he falls down here, he'll be acted upon by gravity, which is controlled by the rigid body. Well, unfortunately, doing the kinds of physics that we want to accomplish with rigid bodies will be actually an uphill battle. We're going to be building a character controller from scratch without using any of the built-in physics. And you might be thinking, well, that sounds a whole lot more complicated than using the built-in physics. It isn't, actually, surprisingly. The built-in physics make it very difficult to handle these sort of scenarios. They also make it difficult to handle scenarios such as moving platforms, as well as slopes and all that fun stuff. So instead of using rigid bodies, we're effectively, or not rigid bodies, we'll still be using rigid bodies, but instead of using the built-in physics, we are going to be writing all of our collision and the prevention of a character from moving into another object, and gravity is all going to be modeled by us, giving us complete control over how we want the game to feel. Okay, so how exactly is this going to work? Well, we're still going to have a rigid body on the player, but it'll be a kinematic rigid body, meaning we'll be in complete control over its movement. We're going to have two scripts. We're going to have the player script and the character controller, so I'll abbreviate that car controller, 2D. So these are our two scripts that we'll have on our player, or two of the scripts we'll have on our player. And the player is going to be taking an input, so input will come in from the keyboard. It'll be processed by the player object, and then the player object will tell the character controller 2D what to do. And then the character controller 2D will handle things like gravity or collision and stuff like that. Now, the way it's going to handle that is the character controller 2D is going to have a velocity. The velocity will be handled in the standard way that anything that simulates any form of physics would handle velocity, and the velocity determines how much, how quickly that object, what speed and direction is that object moving in. And then the velocity will be impacted by gravity. And then we will have collision prevent the player from moving into an object. Now, the way collision is going to work, and let's use a different color for this. The way collision is going to work is that the player is going to be casting out rays. He's going to be casting out rays from his down from the bottom of the player, and he's going to be casting out rays on the direction that he is going. So let's say the player, this is probably more rays than we're going to actually have, but still. So the player is going to be constantly casting out rays. This is assuming that the player is moving to the right and down. The character controller is going to be constantly casting out these rays, and if it hits something, it'll prevent the player from moving into that thing that it hit. For example, let's say that although this diagram isn't perfect, but let's say that this character controller right here, this character, is on the ground right now. That means his down rays, remember, he's moving down. The reason he's moving down is because of gravity. So he'll almost always have a velocity of negative gravity. So gravity is pushing him down, and then the rays are going to be casted down, and it's going to find a hit. It's going to hit right here on this bit of this collider. And when they hit on this bit of this collider, we will measure the distance that the character hit that from the character's position to the collider, and we will clamp his Y position to this distance right here. So this distance is what's preventing the player from going through the world. The same thing will happen if the player were to be over here. So for example, if I were to take this player and move him, oops, I don't want to crop him, I want to move him over here, so now he's colliding with the this wall right here. These colliders, or these ray casts right here, will measure a distance, and that distance will be the furthest the player can move in the X direction before he gets clamped or stopped from moving. So what about jumping? Well, jumping is going to be handled by the player having velocity, or a Y velocity, added to him. So basically, when the player is going up, we're going to have a vector added to his velocity for his jump factor. Now, the velocity changes over time per gravity. Remember, the jump vector will override gravity temporarily, but then eventually his velocity vector in the Y direction is going to get smaller and smaller and smaller every iteration because of the effect of gravity, and he'll fall back down. So right now he's jumping, but let's go ahead and duplicate him and move him over here. Now he's going to be falling because of gravity. And the gravity will bring him all the way down until these raycasts detect that he is going to be hitting another collider. And once he hits another collider, those raycasts will prevent him from going down any further. So does that kind of make sense?
That absolutely makes sense.
Alrighty, there's one more thing, a big thing about the character controller that we'll have to handle, and that is moving platforms. But we're actually going to be handling moving platforms in a separate video because it is going to be a little bit of computation to handle. Okay, so the character controller handles the velocity, the gravity, and the collision. So the character controller is going to need to know things like, is he colliding, where is he colliding, what is his velocity, and what is the gravity of the world, and so on and so on. Whereas the player script is going to handle telling the character controller what to do. So it's going to say stuff like, okay, the player is holding down the right arrow key. We want to add a positive horizontal force to our character controller to nudge it to the right, knowing that the character controller will be casting these rays and preventing him from hitting something like an edge right here. There's one more concept that we need to understand, and that is, let's go ahead and duplicate our player one more time. Duplicate our layer one more time. Well, actually, you know what? I'm just going to move him. I'm going to erase. I'm so good at visualizations, aren't I? What happens when the player gets into a situation like that. You'll notice that if you hit it just right, none of these rays and none of these rays are going to be hitting any geometry, because it's basically going to go inside of the corner. And the player is eventually going to be pushed all the way in, like right here, until those rays start hitting other bits of geometry. So how do we handle that? Well, we handle that with what's called a skin. And the idea is that we actually will be casting these rays from inside of the player just a little bit. So we'll be casting them from here, just inside of the player, and from here, just inside of the player. So that way, when we hit this, we'll have a nice little 2 rays being casted from the lower right-hand corner of the player and the lower left-hand and the upper right and the upper left, depending on the velocity of the player, that will hit an edge of geometry. And we'll define our skin width as something like 0.02 units, so something really small, but it'll prevent our player from getting stuck inside of a edge.
Alrighty, that sounds fun.
All right, so yeah, that's the basis of our character controller. Let's go ahead and just stub it out. I just want to get the public API done for our character controller and for our player object. So I just want to show you guys what the classes would look like, and then we're going to be filling in those blanks as we go along. So let's jump back into Unity and stop the game. And I'm going to come up here to code, and I'm going to create a new C# script, and I'm going to call this character controller 2D. I'm then going to create another C# script called player. Then I'm going to create another one called controller or state 2D. Now the controller state 2D is going to be the like determining, for example, if the player is colliding above, below, right, or whatever. This actually will not be a mono behavior. We're going to be clearing out this file and not make it inherit from mono behavior, because it's just going to be a straight up C# class. And then what we're going to do is we're also going to write a controller 2D parameters. So we're going to say controller parameters 2D. Again, controller parameters 2D will also not be a mono behavior. The controller parameters 2D contains the parameters for the controller. For example, things like what's the gravity limit, what's the slope limit, what's the max velocity, and all that fun stuff. The reason I'm separating that out into a different class as opposed to putting it straight up on the character controller 2D is that I want to be able to override the parameters of a controller if the controller or if the player is in a certain volume. So for example, if the player is in water, I want to be able to override the parameters that are set on the controller. So by changing gravity, for example. Okay, so now I have these 3 classes. Let's go ahead and stub them out. I'm going to hit reload all. I'm going to close out follow path and path definition. So the first 2 I'm going to work on are controller parameters 2D and controller state 2D. That's because these are going to be the simplest ones to work with. Controller parameters 2D. First of all, I'm going to not have it inherit from mono behavior, so I'm going to delete that line. Then I'm going to delete the start and the update from it. So controller parameters 2D will just be a public class, nothing else. So be sure to remove that mono behavior. Next up, I want to mark it as serializable. And serializable that attribute will come from using system. By marking this class as serializable, we'll be able to modify it inside of our inspector if we have a public field on another mono behavior of this type. So I will have a public field on our character controller 2D of this type, and that'll be the default parameters for that character controller. But in order for it to show up properly in the inspector, we have to mark the entire class as serializable. Next up, I just want to get these guys over with. We won't be using them immediately, but because this class is so short, I just want to get this entire class taken care of for the rest of our character controller so we don't have to jump back into it. So I'm going to add a couple members in it that we won't be using quite yet. But I'm going to add a public enum jump behavior. Jump behavior will be can jump on ground and can jump anywhere. And can't jump. So, for example, we'll be able to mark a volume as not being jumpable, or mark a volume as can jump anywhere. For example, in water, you can jump anywhere. You don't have to be on the ground in water to jump if you're looking for a similar movement scheme to Mario for moving in water. Then I'm going to say public vector2 max velocity. Notice that I'm using a vector 2 and not a vector 3. Although our coordinate system is ultimately 3D, we're only really caring about the xy plane, meaning that we can get away with representing the vast majority of our forces and distances in terms of vector 2s and not vector 3s, because that z component is effectively ignored. Now I'm going to set the default to max velocity to be a new vector 2 of float max value and float max value. So the maximum velocity by default is the maximum period, is the maximum float in the x direction, the maximum float in the y direction. Then I'm going to say public float slope limit equals 30, and I'm going to place a range attribute on it from 0 to 90. The slope limit is the angle that we're allowed to climb. So in this case, we can climb 30-degree angles, but we can't climb anything higher than that. However, when we show this value in the inspector, it'll be represented as a slider between the values of 0 and 90. Next, we want public float gravity. And of course, gravity is going to default, let's say default of -25. So that's going to specify that by default, the gravity, or the universal force in the y-axis, is represented as -25. So every second, -25 units in the y direction are going to be applied to our velocity. Next up, just like before, we created an enum, but we haven't used it yet. So let's use it. I'll say public jump behavior, and I'll call this jump restrictions. The reason I'm calling it jump restrictions and not jump behavior is that I can't call a member jump behavior because it'll conflict with the jump behavior type that we defined inside of this class. Next up, I want to do jump frequency, and I'll set that to 0.25. The jump frequency is if they can jump anywhere, we want to limit how often they can jump. We don't want them to just be able to hold down spacebar and continuously jump. We want to limit how often they can repeatedly jump if they can jump anywhere. Anyway, that is our controller parameters 2D. So next up, let's go ahead and create our controller state 2D. Our controller state 2D is going to be responsible for keeping track of the state of the controller, which is why it's called controller state. I love recursive definitions. Anyway, let's go ahead and do like what we just did with controller parameters 2D. We're going to nuke all of that code inside of that, and we're going to make it not inherit from mono behavior. So controller state 2D will not be a mono behavior, and we will just use it as a normal C# class. Now, we're going to have a bunch of booleans. We're going to have public bool is colliding right. Wow, I can't type. It'll be an automatic property. Public boolean is colliding left. Public boolean is colliding above. So are we hitting a ceiling? Public boolean is colliding below. Are we on the ground? Public boolean is moving down slope. Are we moving down a slope? Aptly named. Make sure to capitalize that I there. Public boolean is moving up slope. Are we climbing a slope? Public boolean is grounded. Is grounded is a convenience property for is colliding below. It's just a better better terminology for that particular property. And then we'll have public float slope angle, which is the angle of the slope that we're currently moving up or down of. Next up, we want public boolean has collisions. Has collisions will be return is colliding right, or is colliding left, or is colliding above, or is colliding below. Then we're going to write a method, public void reset. The reset method will be called every frame and will reset the controller state to its default state. So we'll say is moving upslope equals is moving downslope equals is colliding left equals is colliding right equals above equals below equals false. So we're setting is moving up, is moving down, is colliding left, right, below, and above to false, effectively resetting our state. And we'll also want to make sure to set our slope angle to 0. The final thing I want to do is go ahead and create a collision state toString member. So I'm going to say public override string toString. The toString method will return string.format. It's going to look like this. Controller colon R0 L1 A2 B3 downslope 4 upslope 5 angle 7. Okay, so we need to fill in all of these parameters. So the first one is are we colliding right? Second one is are we colliding left? Third one is are we colliding above? Fourth one is are we colliding below? Fifth one is downslope. Sixth one is upslope. Last one is slope angles. That's 6, not 7. Anyway, so this is just a really convenient little toString method that we can use for debugging purposes. You'll also want to add a right parenthesis all the way at the end of that. Okay, so if we invoke toString on this controller state 2D, we'll get a nice little printout of its exact state. So exactly where it's colliding, and if it's moving up or down a slope, and if it's grounded, and the slope angles. So we can use that to do debugging. Alrighty, so now let's look at our character controller 2D. So this is going to be a mono behavior, and I'm going to clear out everything. Before I clear out everything, I did forget to mention one thing. You might be wondering why my controller parameters 2D has public fields for all of its data members, whereas controller state 2D has public properties for all of its data members. Well, the reason is by default, you should always use properties to expose data. That there are, if you're interested as to why there are many arguments online about this, it boils down to it's not going to be any faster or slower than a public field, but it does give you a lot of safety particularly in binary compatibility. It's really just good form. You should always, as much as you can, express all of your public data as a property, even if it's just an automatic property with a public getter and a public setter. However, controller parameters 2D is something that I intend to be able to manipulate within the inspector window. Because I intend to manipulate that within the Unity inspector window, the Unity inspector window has a constraint that it can only manipulate fields, either public or private fields of that class. So as a result, I'm constrained to using fields for the controller parameters 2D, but I'm not constrained to using fields for the controller state 2D because I'm not intending to edit this within the Unity inspector window. So jumping back into our character controller 2D, let's go ahead and just stub it out. So I basically just want to create all of the definitions of all of our methods and some of our pieces of data, and then I'll use that information, or we'll use that information in subsequent videos to implement our character controller 2D in full. Let's start off by writing our constants. So I'm going to say private const float skin width equals 0.02f. So remember the skin? This is what we're defining it as, 0.202f. Then we're going to say private const int total horizontal raise equals 8. As you can see in this diagram, the character is going to be constantly spitting out rays horizontally and vertically, and we want to define how many of those rays should we want. So by specifying 8, that means there'll be 8 arrows to the right or to the left of the character controller that will be evenly spaced out over his collider. Then we're going to say private. The reason I write these as constants is they just make it really easy to tweak them. I suppose I could also expose these as public fields of Character Controller 2D, and if you want to, you're more than welcome to. But I found that the values that I came up with, or have been using, 8 and 4, work just fine. So if you want to optimize them or tinker with them, you can. That's why I'm turning them into constants. And by turning them into constants, I also get significantly more readable code. But they could also be public fields if you wanted to. So then we'll say total vertical raise equals 4. Then we're going to say private static read-only float slope limit tangent equals mathf dot tangent 75 degrees times mathf degrees to radians. We have to multiply our degrees by degrees to radians because all of the Unity math functions expect radians. We'll be using this when we implement our moving up and down slopes. Okay, so let's go ahead and write a couple other things, just arbitrary things that we know we will need. We'll be adding more data to it later, but I want to get some of these variables written out first. So I'm going to say public layer mask platform mask. Now the platform mask is going to be a layer mask that's going to be used for the collision detection. Basically, we're going to have it so that the only things we collide with are things that match this platform mask, this particular layer mask. So that means we won't collide with, for example, a star or a health pack. We'll just walk right through those, but we definitely want things like the ground to be on a layer that we can only target through the character controller's platform mask. Then we want public controller parameters 2D default parameters. So this is where our things like max velocity, slope limit, gravity, jump restriction, jump frequency, that's where they come from. This allows us to edit the default parameters within the inspector. Remember that the controller parameters 2D class is serializable. Okay, so what else do we want? We want a public collision state or controller state 2D, and we'll just call this state public getter private setter. Then we want something like, I think that's all we really want to implement right now, as far as public fields. We'll be adding more and more to these every video in this little mini series on creating a character controller, but for now we'll just leave it like this. Now let's go ahead and just stub out our methods really fast. So the methods that we're going to want are public void awake, where we're going to handle initialization. We want public void initialize, or no, we don't want initialize. Whoops. We want our public void add force vector2 force. So we want to be able to add force to our character controller. We also want set force vector2 force. That'll set our force. We'll also just want some really basic other helper methods. I found having a set horizontal force method, so float x, and then a set vertical force float y. I found those helper methods cleaned up my code a little bit. Yes, they're a bit redundant because of our velocity being changeable from, well, actually no, our velocity won't be changeable from the outside, but these methods, what they'll allow us to do is just set one component of our velocity very straightforwardly. Straightforwardly. I don't know if that's the proper use of the term. I don't know if it is a term, but I hope you guys know what I mean. Anyway, so now we have our set vertical force. Let's go ahead and add a jump method. I want jumping to be a part of the character controller, even though typically it isn't, but we do want it to be part of the character controller here. We want a late update method. We're not going to be doing an update method because there are a lot of calculations that need to be performed to handle things like moving platforms that will be handled inside of the respective update methods of the other objects. So we'll be doing most of our logic in the late update method so that we can be assured that the other update methods of all the other game objects have already been invoked. We want a private void move, vector2 delta movement. So the move method will be private. We might decide to make this public later, but I like keeping things private by default. We want a private handle platforms method for handling our platforms. We want a private void raycast origins method, or calculate ray origins. I don't think that's how you spell origins. I think that's how you spell origins, but I might still be wrong. But then again, you didn't come here to learn spelling. The calculate ray origins method will be invoked on every lay update, and what it's responsible for is pre-computing where the rays are going to be shot out from based on a variety of different parameters and the position of the current player, or the current position of the player. We'll definitely want a private void move horizontally. Now, the signature of this method is going to look a little interesting. It's going to take a ref vector2 delta movement. Why does it take a reference to delta movement? Well, because it needs to manipulate delta movement. Remember, delta movement is going to be how much movement, or what the velocity of the player currently is on that frame. The move horizontally method will be responsible for making these raycasts, and once it finds a raycast that hits another collider on another object, it needs to constrain or clamp the X movement so that it doesn't cross the object that the ray hit. So, to do that, we need to make sure that the move horizontally method can modify the delta movement based on the existence of a platform being to the right or to the left of the player. Next up, we want move vertically. Move vertically will also have a vector2 delta movement. Move vertically differs in move horizontally only in the case that it's invoked every frame, because we will always be moving vertically because of gravity. Gravity will always be applied to our object. Our object will always try to move vertically every frame. And the same sort of thing, it needs to take a reference to the delta movement so that it can manipulate the delta movement based on if we are colliding on the ceiling or if we're colliding on the ground, to make sure that the player can't jump through the roof and can't fall through the ground. Next up, we need a couple other methods that will be similar. We want to handle vertical slope. Handling the vertical slope will allow us to move up slopes, or slopes that are verticalish, or our vertical movement on a slope, rather. Then we want to handle the horizontal slope. Handle the horizontal slope will take in a vector2 delta movement, a float angle, and a Boolean is going right. So these the angle and is going right will be computed by the method that invokes handle horizontal slope. And then I think that pretty much wraps up most of the movement for the player. The other things that we'll need for our character controller in the future is going to be public void on trigger enter 2D collider 2D other, and then public void on trigger exit 2D. Collider other. The reason we on trigger enter and on trigger exit, remember how I said that the controller parameters 2D class can be overridden? Well, it's going to be overridden if the user or if the player falls into a volume that is set to override those parameters. To detect the existence of those volumes, the character controller 2D is going to have to be notified when the player enters a trigger volume or exits a trigger volume. And we'll talk a little bit more about that later. You'll notice that I'm also referring to these as collider 2Ds, and I'm also saying on trigger enter 2D. That's because we're using 2D colliders and 2D rigid bodies to handle our movement for the game. These are new components and new methods that have been introduced in Unity 4.3. We'll talk a little bit more about the colliders available to us in a later video when we actually set those colliders up in our level. Okay, so that pretty much shows us what our controller method is, our controller class is going to look like. The great thing about this controller class is it's going to be very very flexible, and it's going to allow us to do things like create artificial AI components as well as creating player movement. So yeah, I think that pretty much wraps up our character controller 2D's interface. I think in the next video what we're going to do is we're going to set up and instantiate our character controller 2D, our player, and then we're going to write code in our player class that actually invokes character controller 2D. Because although these methods don't do anything yet, we can still invoke them from our player, and we can see how to use the character controller 2D before we implement it, which should give some perspective on how to handle this. One last thing I'll point out, if you want to know more about this method that I'm using, there's a, Steve, what's that site? Game Strata? Game Sumatra?
Gama Sutra?
Gama Sutra. There's a Gama Sutra article on this particular implementation of doing a two-dimensional character controller that has a couple more diagrams and mostly just talks about this this from a higher level, whereas here we have a more of a concrete implementation with some modifications. But anyway, I think that just about wraps this video up, so we'll see you guys in the next one.